Hello everyone, in this video we're gonna explore the antiderivative of cosine to the n of x ds. We have two different cases. The first case, n is even or n equals 3. We're gonna use the formula right here. Sine square of x equals 1 minus cosine 2x over 2. Cosine square of x equals 1 plus cosine 2x over 2. And sine cube of x equals negative sine 3x plus 3 sine x over 4, and cosine cube of x equals cosine 3x plus 3 cosine x over 4. Alright, so we have two different things we need to do. The first thing is n is even. Alright, so for example, if I have cosine to the 6x ds, right? So this case I resolved in the previous videos. So please look at the description below. You will see the videos about this one. Now I'm going to do the second one right here, n equal to 3. So basically we need to calculate the antiderivative of cosine cube of x ds. Now this one can be written as the integral of cosine square of x times cosine of x ds, right? So cosine square of x, I just break it down into 1 minus sine square of x, right, times cosine x ds, right? So this one can be written as 1 minus sine square of x. Cosine x ds is gonna be d sine x, right? Because the derivative of sine x equals cosine x, right? Alright, so it's gonna be sine x minus 1/3 sine cube of x plus c. Alright, so this is the answer for the integral of cosine cube of x ds. Now second case, n is odd and n must be greater than 3. Alright, so in this case we must use the binomial theorem. So recall. Alright, if I have a plus b raised to the n, and then I'm going to use binomial theorem to expand this one. So this turns out to be the combination of 0 and a to the and b to the 0 plus 1 and the combination of 1 and a to the n minus 1 b to the first plus combination of 2 and a to the n minus 2b squared plus etc. plus the general terms is going to be k and a to the n minus k b to the k, and plus the last term is going to be n and a to the 0 b to the n. The second one, if we have a minus b, right? So we have a minus b to the n. It's going to be the combination of 0 and a to the n, and then b to the 0, right? So this one right here, we have the negative side right here, we put negative 1 all together, power of 0 right here, right? Next one, the combination of 1 and a to the n minus 1 b to the first, right? So we put negative 1 right here, right to the power of 1, right? Next one, we have combination of 2 and a to the n minus 2b squared. Alright, so we put negative 1 right here, right to the power of 2 right here. Okay, right? The power of negative 1 right here depends on the power of b right here. So keep that in mind. Okay, so in general, I have the general term plus etc. plus the combination of k and a raised to the n minus k b raised to the power of k. So I have negative 1 right here raised to the power of k. And the last terms, it turns out to be the combination of n and b raised to the power of n, right? So this guy turns out to be times negative 1 power of n, right? Now we have the integral of cosine s to the n ds. Now keep that in mind, n is odd and n greater than 3. So n could be written as 2p plus 1, right? And p must be greater than or equal to 2. Alright, so this one turns out to be the integral of cosine s raised to the 2p plus 1 ds, right? Now this guy right here can be written as cosine square all together power of p, right? So cosine square can be written as 1 minus sine square, right? So it's going to be the integral of 1 minus sine square of s raised to the p cosine s ds, right? But cosine s ds can be written as d sine s, right? Alright. Now, I use the binomial theorem right here. I need to expand this guy, right? So this guy turns out to be the integral of combination of 0p, right? 1 raised to the power of p sine square of s all together raised to the power of 0. And don't forget to multiply by negative 1 raised to the power of 0 right here. Alright, next one, I'm gonna add the combination of 1p, right? 1 raised to the power of p minus 1 sine square of s raised to the power of 1 times negative 1 raised to the power of 1 right here. Alright, plus combination of 2p 1 raised to the power of p minus 2 sine square of s raised to the power of 2 times negative 1 raised to the power of 2, right? Alright, plus etc. plus the general terms, combination of k, p, 1 power of p minus k, sine square of s power of k, then negative 1 right here, right to the power of k, right? Plus, etc. until the last two terms. Now, the terms from the last one should be combination of p minus 1, p times 1 raised to the power of 1 sine square of s raised to the power of p minus 1 times negative 1 raised to the power of p minus 1. And the last one is combination of p, 1 raised to the power of 0 sine square of s altogether raised to the power of p times negative 1 raised to the power of p, right? Alright, so we need to simplify this one. So this guy turns out to be combination of 0, p. 1 raised to the power of p is going to be 1. Sine square of s raised to the power of 0 is going to be 1. Now negative 1 raised to the power of 0 is going to be 1, right? So the first one you only have this guy, right? Now the second one right here, because negative 1 raised to the power of 1 is going to be negative 1. So I put negative sign right here. Combination of 1p, right? This guy right here equal to 1, right? Sine square of s raised to the power of 1 is going to be sine square of s. Plus the next one right here, combination of 2p. This guy equal to 1. This guy equal to 1. This guy equal to sine to the 4 of s, right? Next one plus etc. plus the general terms. It's going to be right here. Combination of k, p. This guy equal to 1. This guy equal to sine raised to the 2k, right? Right? Times negative 1 raised to the k plus etc. plus the last two terms right here. The combination of p minus 1p. This guy equal to 1. This guy equal to sine to the 2 p minus 2 of s, right? Times negative 1 raised to the p minus 1. And the last term, the combination of p. This guy equal to 1. This guy equal to sine raised to the 2p s times negative 1 raised to the p, right? Don't forget d of sine s, right? Alright, the last step is to take antiderivative of this one. So this is a constant, right? So the antiderivative of this one should be the combination of 0p sine s, right? Because we have d sine s right here. Minus 1/3 sine q of s, right? And then the combination of 1p we need to put over here, right? Plus 1/5, right? Sine to the 5th s, and this one the combination of 2p, right? Alright, plus etc. plus the general terms right here. It's gonna be negative 1 to the k, right? The combination of k, p. Then sine of 2k plus 1, right? And then you need to divide by 2k plus 1. So you need to put it right here over 2k plus 1. Negative 1 to the p minus 1, we need to rewrite it right here. Alright, then this one right here, we need to rewrite it, combination of p minus 1, p, right? Sine to the 2p minus 2 of s, it turns out to be sine 2p minus 2 plus 1 is going to be 2p minus 1 of s, right? And then you need to divide by 2p minus 1. Alright, and the last terms right here, it turns out to be negative 1 to the p. Alright, over this guy right here, 2p plus 1, right? 2p plus 1 of sine to the 2p plus 1 of s. And then you need to rewrite the combination p of p, right? And then don't forget to add c. And then this is your final answer. For this one right here. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.